Hello. In this work entitled Optimization of Wind Farm by Adjusting the Pitch Angle and Minimizing Wake Effect, I will present a new approach for optimization of a wind farm. The evolution of the establishment of wind farm in recent years pushed the designer of wind farm to provide more effort in the optimization in order to reduce the effects of wake and maximize power. The objective of this article is to study the optimization of the pitch angle of each wind turbine in order to maximize energy production and to minimize the total investment cost in a wind farm. The reliable analytical Gauss model, including the effect of turbulence, was chosen in our study. The genetic algorithm with a defined the objective function allowed to maximize and minimize the wake losses using the optimization of the angle pitch for each turbine. The the Gauss model developed by Bastang, Kach, and Port Agel is based on the law of conservation of mass and the law of conservation of momentum. As shown in figure number 1, the speed distribution is a Gaussian, so the deficit of speed can be calculated in equation number 1. Energy calculation of a wind farm. The power produced by a turbine is a function of pitch angle beta, power coefficient Cp, air density ρ, radius of the wind turbine r, wind speed u, and the speed ratio lambda. Its expression is noted in the equation number 2. And we can finally conclude the final power of a wind farm, which is the sum of the power of each turbine calculated in the equation number 3, where UWE real wind speed of the position of the A30 wind turbine calculated considering the wake effect. Case study. The Hans Reeve wind farm was built in 220 and is located in the North Sea, some 14 to 20 kilometers from the coast of Jutland. It has 80 Vestas to megawatt wind turbine with a total power of 160. The turbines are arranged in 8 rows and 10 columns with a distance of 70 between each two wind turbines. Dominant wind direction is considered 0 degree. The table 1 summarizes this information of the studied wind farm. Site roughness, mean wind speed and wind direction, wake decay coefficient, and the air density. Methodology, objective function. The objective function proposed in this article aims to maximize power through optimal pitch angles and minimize the cost of wind farm by exploiting genetic algorithms. In the calculation of the optimal objective function, the analytical model for the wake and the power coefficient resulting from the analytical equation allowed use to show the meta-heuristic technique, hence the use of genetic algorithm. The objective function denoted by function objective is written as objective function equal max P total by cost. Methodology, objective function. We start by the input data and the genetic algorithm and initiation population evaluation of objective function, selection, crossover, mutation, generation of a new wind farm with a new setting of beta, number of iteration is satisfied, yes, optimal solution, or no, and we start the evaluation of objective function. Results and the discussion. The nominal operation of the turbine is generally dependent on the power coefficient, but it should also be noted that we can obtain power curves as a function of the wind speed and the various pitch angle setting. The case of step angle studied in our article is for beta is is for beta, and we can compare beta with the 0 degree. Uh, Result and the discussion in the figure number 4 and 5 represent respectively the power produced for each wind turbine by the classical method and our optimal method by the choice of the optimal step angle. We can clearly see from figure number 4 that the power in the first column exceeds the value obtained by our optimization algorithm is quickly caught in the second column as shown in figure number 5. This improvement, which is around about 10.3%, is explained by the compensation due to the airflow distributed by the effect of the upstream wakes. Uh, in the figure number 5, number 5 show that the turbine is in the column 0 all operate with a negative pitch angle value. Therefore, we with a power output lower than the rated power for the average wind speed. In the column 7, 14, and 21, the last column take the value beta equal 0 degree for its pitch angle. So they operate at the maximum power. Uh, a sensitivity analysis for evaluating the approach used in our article is shown in figure number 6. As can be seen, the optimization proposed by the genetic algorithm to allows to increase the power in the speed range of engagement in the 16 meter by second. On the other hand, for high speed, the energy production is the same because all the turbines operate at nominal power. Conclusion: in this article, we try to introduce an optimization method by controlling the pitch angles and minimizing the cost based on the Gaussian wake model proposed. We also try to exploit the turbulence effect, which makes it possible to recover speed losses in the wake zone. The results of this article have shown that new approach using a genetic allows to increase the power of a wind farm by acting on the pitch angle of each wind turbine by exploiting the added turbulence and its effect on the recovery speed. Thank you for your attention.